Hello everyone, today we are going to continue our solving trigonometry for each 5. We are now in question number 38. Find the value of sine 120 degrees. So we have to think how to find the value of sine 120 degrees. So we have to do our solution first. Sine 120 degrees. So we will get the reference angle first. So in our previous video, so since the given is 120 degrees, which is more than 90 degrees and less than 180 degrees, so our basis of computation 180 degrees minus 120 degrees. So the reference now is 60 degrees. This would be our reference angle now. So instead that we're going to sine 120 degrees, we will use sine 60 degrees. How to get this number? Our basis is the opposite and hypotenuse. And I have here a drawing illustrative. So in a special triangle, 60-30 degrees, 60-30, 90 degrees. So in a unit circle, the opposite of 30 degrees is automatic 1. And the hypotenuse, we're going to add 1 plus 1 equals 2. Or multiply by 2, 1 times 2 equals 2. Then to find the 60 degrees, here, the side of 60 degrees, the opposite here. So we will use the Pythagorean theorem. Remember the formula is c squared is equals to a squared plus b squared. And since this one is the one leg of a triangle, so we're going to multiply, we're going to square this. 1 times 1 equals 1, and 2 times 2 equals 4, then 4 minus 1 equals 3, then square it. So that's why the opposite of 60 degrees is equals to square root of 3. Now, here, since we're looking for sine 60 degrees, so this sine here is this opposite of this 60 degrees. So that's why we have now the formula of our computation, opposite and hypotenuse for the sine, and the opposite of 60 degrees is square root of 3 over the hypotenuse, which is number 2. So that's why we have here the denominator of 2. So our final answer for sine 120 degrees, which is equivalent to sine 60 degrees, based on the reference angle, and our final answer for sine 120 degrees is equals to square root of 3 over 2. Okay, next, number 39. Find the value of cosine 120 degrees. So again, we're going to determine the reference angle of cosine 120 degrees. So remember, 120 degrees is less than 180 degrees, more than 90 degrees, or the other one is more than 90 degrees but less than 180 degrees. So this will be our basis now. On computation, 180 degrees minus 120 degrees equals 60 degrees. So it becomes now the cosine 60 degrees. So our base of computation is adjacent over hypotenuse. So we have again here our illustrative special triangle, 60 and 30 degrees. The same, we're going to automatically put here 1 in a unit circle, and 1 times 2 equals 2. Then 1 squared equals 1, 2 squared equals 4, 4 minus 1 equals 3, then square root of 3. So this will be our the opposite of the 60 degrees. Since sines, our formula is adjacent. If this is the opposite, so the adjacent is here 1 and the hypotenuse is 2. That's why the adjacent is 1 and the opposite hypotenuse is 2. So our cosine 60 degrees is 120 degrees, is 1/2 rather, which is equivalent to cosine 120 degrees. Okay guys, number 40. Using the fundamental identities, find the value of cos theta if secant theta is equals to square root of 2 over 3. Theta means the angle. Okay, now, since in these questions we are required to use the fundamental identities, this fundamental identities, this is equivalent to our formula now, and one of the formula is the cos theta is equals to 1 over secant theta. So this will be now our formula because they given secant theta square root of 2 over 3 and the cos theta. So this is the applicable formula that we're going to use and this function expression. Now, upon writing the formula, we have to do is to substitute from the given equals 1 from here over secant theta, which is equivalent to square root of 2 over 3. That's why we have here 1 over square root of 2 over 3. So it becomes now complicated fraction. So we have to do this to find the answer for this. So we have to, and the numerator, we're going to look for the denominator of 1. So the denominator of 1 is equals to 1 times the reciprocal of this denominator. The reciprocal of this denominator now is 3 over square root of 2. Then we're going to apply the multiplication horizontally. 1 times 3 equals 3. 1 times the square root of 2 is equals to the square root of 2. This time we cannot end our computation here because there is a radical at the denominator of fraction, which is not allowed. So therefore, we're going to rationalize this. So we have to copy first the question, 3 over square root of 2 times the rationalizing number. So how to rationalize? We have to think for the denominator that if we're going to multiply, it becomes a perfect square root of a number. So that's why our suggested now is square root of 2. So square root of 2 times the square root of 2 here. So then we're going to multiply horizontally. 3 times the square root of 2 equals 3 square root of 2. Then the square root of 2 times the square root of 2 is equals to the square root of 4. Then after that, we're going to simplify here. So this one is already simplified. 3 square root of 2 we cannot do this time. So this is the simplified number. But the square root of 4 is not. So we're going to get the perfect square root of 4. So the perfect square root of 4 is 2. So this will be now our answer. The cos theta is equal to 3 square root of 2 over 2, which is the given is secant theta over is equals to square root of 2 over 3. Okay, guys. Okay, next, number 41. Factor the trigonometric expression 1 minus cos squared theta. Okay, the question for number 41 is factoring. So we're going to factor the trigonometric expression 1 minus cos squared theta. So our solution, we're going to use the formula. Let's go back our experience in algebra that in this given is the same like this. Okay, for example, this is called the difference of two squares. So to find the difference of two squares, so this algebra, okay, we're going to find the factor of x. So the factor of x and x. But first you have to write two parentheses. And you're going to put the factor of x and x. Then next, since we have negative here, our pattern is one negative and one positive, or rather one positive or negative. No problem with that. So this time our example is negative, and the next is positive. And we're going to find the factor of y, which is y and y. So this is the answer now. So based on this formula, algebra, so we're going to factor this given trigonometric expression. So that's why our factor of this is 1, copy first, minus cos squared theta is equals to the two parentheses now. then the factor of 1 times 1 equals 1, and here the cos squared, the factor is cos theta minus first, then positive cos theta. So this will be now the factor of this given trigonometric expression. Okay, next, number 42. Find the factor of sine cube theta plus cos cube theta. So the given is just like the sum of two cubes. So in algebra, so this is our basic formula. So how to find the factor of this sum of two cubes? So we have to copy the x and y here, one parenthesis, and we will make another parenthesis which is for the trinomials. So after writing x and y here, and the next parenthesis, we're going to find the squared of x. So x times x equals x squared, and we're going to write, if this is positive, it becomes now here negative, and we're going to multiply x and y. So that's why we have xy. Then find the square of y. So y times y equals y squared. So this is based on the formula in algebra. And to factor this trigonometric expression, sine cube theta plus cos cube theta is equals to the first parenthesis, which is copy the sine theta and cos theta, and also copy the addition here, sine. Then, or the plus sign. Then make another parenthesis for the trinomials from here. So we're going to find the square of sine theta. So it becomes now sine squared theta. Then since it is positive, it will change now to negative. Then we're going to multiply the sine theta and the cos theta. So that's why we have sine theta and cos theta. Then plus here, remember, in our formula. Here, always addition here, always plus here. Then we will find the square of this trigonometric function, cos theta, it becomes now cos squared theta. So this will be our final answer for this question.